Hey data people, welcome to the second tutorial on polars. In the previous part we've talked about some of the basic operations that we can do in polars and how to perform basic exploratory data analysis, doing some univariate, doing some multivariate, and just doing general checks of the quality of the data. This part is going to be a bit more advanced, so if you need a refresher, make sure to check out my previous video. Otherwise, let's jump into it. This video again is going to be a walkthrough the notebook that I've prepared for you. So make sure to download it and follow along. In this video, I want to focus on the group by operation that allow us to aggregate feature by category or by some date type object, for example. And it's going to be useful to cover group by dynamic and group by rolling. And also I want to introduce you to some of the common namespaces that you can use when you work with your data set to do maybe some feature engineering, maybe some pre-processing. You can find all of them here inside of the series tab in the documentation. And in this notebook, I think I'll be covering the temporal, some of them. So transformation to a datetime object and extraction of different elements from the datetime. And I will also be working with strings to do some string manipulation. If you're interested in the documentation, you can check out the Polars website where I'm currently at. Otherwise, make sure to pull the latest version of my GitHub called tutorials. And inside of the polars folder, we're going to be working inside of the time analysis notebook. Also, make sure to download the data we've used previously. It's called YouTube trending. If you just Google YouTube trending Kaggle, it should be right there. Make sure to download it and put it inside of the folder where you will be able to access it. And now that the prep is done, let's jump into the notebook. I'm going to be using VS Code, but you can use whatever IDE you want. First things first, let's run the imports. Everything is already installed. Here is the polars, and it is a convention to import it as a PL. And let's set some of the configs. As I've shown previously, setting this allows us to see wider tables. And now loading the data. This is the Kaggle data that I've talked about. I've put it into the YouTube folder, but you can put it wherever you want. And also reading in categories JSON file. Similar to the previous tutorial, I'm going to be transforming the category IDs to the actual category names, just for the sake of readability. And let's set the date column format. Here I'm using a dictionary, as you can see. I'm going to set trending date to just a date and publish time to a datetime format. Once all of these things are defined, we can start with pre-processing. The first function that I've created here is called parseDate. It takes as an input a data frame, a polars data frame, date calls, which is a dictionary of string to string, and this is exactly that, so date column format, and it outputs a pre-processed data frame. As you can see here, it iterates over this dictionary, builds up the expressions, and then applies them to the data frame. Again, very similar to what we did last time, where we saw a function where you can build up your expressions and then just apply them once. This is done to speed up processing because polars uses multi-threading and parallelization very efficiently, but you need to make sure to build up all of your expressions and only then pass them to the with columns or select clauses. Keep that in mind, it's an important hack to speed up your polars code. And then you can see that I'm applying this function to my data frame. This is a raw data frame that we saw above. And date column format, providing it from the specified here, and then mapping the dictionary that was read in using the JSON here to a column called category ID to map it from integer to a string. So let's run both of those. And this is how our data frame is going to look like now. As you can see, trending date is processed as a date. Publish time is also processed as a date in the required formats. And most importantly, the category ID, where it is here, it's no longer an ID, but it is a string. And now that the data is processed, let's do some interesting feature engineering. First thing that we can calculate is called time to trending. It subtracts publish time from the trending date, and it allows us to measure how many days it took for the video to go from publishing to trending. The next three features are ratios. It is likes to dislike, likes to views, and comments to views ratios. And they just allow us to measure how, in general, was this video more engaging, was it less engaging, was it more disliked or liked, and allows us to measure some interesting patterns. And finally, I'm printing out just the samples to see how does the data look like. So let's run this. And here's how the data looks like. We can see that it took 7 days for this video to go to trending, but for this video it took 25 days. There is of course variation between when videos go to trending. And now let's just visualize how does time to trending feature look like. We're going to do this using haze plots just to make sure that there is no huge outliers and that it looks fine. So we can actually, maybe not haze plot, maybe let's use box plot instead. We can do df select. Remember, this is the method to select your columns. And then we can either just provide a string or we can do pl call string. In this case, I guess I could have just made a string because syntactic sugar takes care of transformation. And so from here we can do, for example, to numpy. And let's just make sure that it is one-dimensional, because sometimes, I guess in this case, it's going to return it as a two-dimensional object, and boxplot shouldn't really be handling that. So we can see here that there are indeed quite a few outliers, which is going to be a challenge that we'll need to deal with later. For now, let's delete it and let's move on. Next feature engineering step we're going to do is to transform date column into numeric features according to their weekday, month, and year. This is similar how you would do this in Pandas. Again, I'm working through this date time namespace and then selecting month, year, and weekday. And you can print it out here. You can see that it's going to look like this, right? 2017, and yeah, so it looks like it's working. Then the next step, we can split the tags. This is more of a, just for practice to show you which different available methods there are, but for the analysis we don't actually need it. Regardless, here we're going to select tags and we're going to select the string namespace because this is a string. And we're going to split it according to this parameter. And if you look at this column here, you can see that different tags are assigned to the videos with separators as lines. And that's what we're doing here. Very similar to Pandas. I think even the syntaxes would be the same, with the exception, of course, that with columns. So you would be doing this directly on the column. And we can see that this is how let's actually select the tags themselves. Yeah, so now they turned into lists. You can even see that this is list of string. Very nice functionality of polars that it lets you see the data types of the columns. And let's save the process data just for the future use. In the analysis section, we can start with simple group bys, but they allow us to answer some very complicated questions. For example, if I ask myself, what's the median time to get to trending tab for a video? This could be a simple question that we just calculated, using this feature engineering effort here. However, we have a problem. Our problem is that video can appear multiple times in this data set. Let's select one example and see what I mean. df sample to select a random video. And let's say that we want to find it here. If you remember, we are using df.filter to filter our data set. And here I'm going to be, that's a typo. I'm going to be saying, okay, video ID is equal to this one. We can see that this particular video appears 11 times and it kind of just goes into trending at the December 8th, then exits trending December 18th. So overall it's in trending 11 days, but the actual time where this video took to get to trending is 2 days. Luckily for us, we calculated this. From this, we can see that the number of days, the actual number of days it took this video to get into trending is the minimum out of this column. What we want to do, we want to aggregate, group by the video ID and select the minimum number of days it took to get to trending, because then it's going to give us the truthful number of days it took to get to trending. And this is exactly what I'm doing here. You can see here that I'm calculating time to trending. So inside of this group by, I'm doing an aggregation and then I'm selecting this column, time to trending, doing a minimum, and then accessing a date time and accessing the days column. What it does, it just transforms 2 days to 2 as an integer for the ease of calculations later on. But also we can see that we can calculate more things here. So we can calculate what was the first day in trending or was the last day in trending using the trending date and applying minimum and maximum. We can also calculate the number of days in trending, because the difference in the last day in trending versus the first day in trending is going to be the number of days it was in the trending category. All of this stuff will be useful for us later on when we ask more complicated questions. And now that we've done the aggregation, let's print it out. Oh, and one thing, why am I doing all of this stuff here? It's because I want to propagate these values to my aggregated data frame. You will see here that when I run it, all of these values still appear here. But if I didn't do this, then I will need to rejoin them later to the aggregates, and this would be a pain. So instead, I'm just aggregating them all together, because in theory, it should be one-to-one here. So one video ID should have a unique title, should have a unique category ID, and should have a unique channel title. Reality is not that simple. There are like some videos that were renamed, for example, or there are some videos that were for some reason assigned to different channels. Maybe it was a collaboration of some sorts, but I'm ignoring all of these edge cases and just simplifying it here. And here's how it looks like. We can see that the time it took to trending, for example, to a Jeremy Clarkson thinks about blah, 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 Mashable Daily. It took 2 days to get into trending. That was the first day, that was the last day, and it was 11 days in trending, which is very nice. The interesting thing here is that we can see that average time to trending is 36 days, but the median time to trending is just 2 days. This is because of these outliers that we saw previously, right? We saw this box plot with huge outliers. So I would recommend applying a filter here to separate these outliers. Usually 60 should be more than enough days to get into trending, and if something got into trending after 60 days, this is definitely an edge case and you shouldn't include it into your analysis anyways, or you should analyze it separately. And let's print it out with the filter data, and now it looks much better. So we've answered the first question that we asked ourselves: what's the median time to get into trending? And looks like it's 2 days, and the average time to get into trending is 3.7 days, disregarding the outliers. The next question that interests us is which categories consistently achieve the fastest trending status, and I actually also want to explore it for the channel titles as well. Here I've created a function to do this, but it might be a bit complicated, so let's break it down bit by bit. What I'm doing here is, first of all, I'm calculating a times in trending variable, and this variable allows me to calculate how many times category or a channel or essentially any other ID appears in the trending tab. And I use it to then filter out the channels or categories that don't appear enough times in the trending to make sort of conclusions. Because imagine that if a channel got into trending once and this channel got into trending, let's say it took it 1 day to get into trending. This is going to be the fastest channel to trending, but it would not be a reliable measure because this channel or this category only appeared once. Instead, we want maybe to set a threshold to 100, like I do here for the category IDs. So a category needs to be in the trending at least 100 times for us to make a conclusion, and for a channel to be in trending at least 10 times, which is very impressive, to be able to make some sort of conclusions about how long it takes for this channel to actually get into trending. The first thing I'm doing is I'm calculating this variable, which is called times in trending. And what it does, it essentially calculates the number of counts that the category has appeared in the trending dataset. And here I could do this using value counts like you would usually do in this type of analysis. But here I just want to introduce a new functionality. So this is an analytical function over very similar syntaxes to SQL. So it shouldn't be that unfamiliar to you. And let's try to calculate it manually. I'm going to go with columns, and let's just copy paste all the names, just to make sure that we don't make any mistakes. And then copy paste this. Of course, we substitute by. by the column of interest, and in this case it should be category ID. And we can see that, yeah, so this is how it looks like. Times to trending, for example, these two videos, they are the same category, so they have the same value, times to trending, and this makes sense. Then we can apply our logical filter that if a category appeared less than 100 times, then we don't want to analyze it because it's not enough data. And we can see that filtering is very easy with new columns that we've just created. You can literally pass it as a PL call, and then we want to filter everything that's more or equals to 100. And let's format it like this. So this is our data frame that we're going to be working on. Now, two steps that we need to do is to group by the category ID and then calculate the average of the metric of interest. In this case, our metric of interest is time to trending, and we're going to end up with the data frame that shows us what's the average number of days it took for a category to get into trending, which is exactly what we want to answer the question. So let's group by category ID, and let's make an aggregate out of time to trending. Let's calculate the mean, and finally in the function I'm also sorting by time to trending, so we can do this as well just to keep it consistent. And there we go. This is going to be our result. Comedy is the fastest category to get into trending, and the slowest is film and animation and people and blogs. Interesting stuff. So we can delete this now. Now you understand what this function is doing, and you can see that it also works if we, for example, supply by the channel title. It's going to do the same thing but for a channel title. And we can run it like this, and this is how it looks like. It prints out the first 3 rows. So here the comedy, how to style and sports are the fastest to get into trending, but then the channels that are fastest to get into trending are Tonight Show, Saturday Night Live, and Ellen Show. So the tip of the late night shows. So we found out who gets into trending fastest, but who actually stays there the longest? That's also an important question. And we can use the same function we've just designed to answer this question. What we want to do is essentially the same, right? We want to group by a category ID or a channel title and then make some sort of an aggregate. So in this case, we want to calculate an average for the days in trending value that we've calculated before. And that's why we can reuse the same function that we designed here. Again, thresholds apply. Only categories that appeared at least 100 times are going to get calculated. And we can see that actually, interestingly, entertainment, film, animation, and music stay in trending the longest. This is in contrast to comedy, how to style, and sports that get into trending the fastest. So speed is not always quality. And then let's go to the channel, and we can see that Wired, HBO, and Entertainment, whatever that is, stays in the trending the longest, which is, again, none of the channels that we saw here. So again, very interesting discrepancy. So that's how you use group by in polars, right? It's nothing too complicated, very similar to Pandas. But now let's move on to more complicated types of group bys. In this case, I'm talking about group by dynamic. We can use it to answer questions like which categories are the most popular or like the most trending per month or per day or like at any other time period that you can define. Ignore this top categories for now. Here I'm just calculating how many times category appears and selecting the first 7. That's going to be used for plotting a bit later. But here is where the group by dynamic gets applied. So the first argument to supply is the index column. This is usually going to be your date column. In this case, it's a trending date. Then you have this argument, which is called every. Here I'm specifying every 1 month. I could also specify maybe every week. So that would be 1 week or even 1 day. But for now, I'm just doing 1 month. And then close, it specifies which boundaries do you want to make inclusive or exclusive. And then I'm also specifying include boundaries true to make sure that I output these boundaries just for my own kind of sense checking. But usually in the real life, you don't want to output them because that's not the features of your interest. And it just takes time to calculate them. And finally, we're specifying by argument. By is the column by which you want to aggregate. In this case, it's a category ID, but we could also do a channel title if we wanted. So once we've done this aggregation, we can provide similar type of aggregations that we did for group by. We're doing a video ID and then calculating number of unique videos that this category has. And we provided a title. Now we use alias to do this, and this is video number. So just to summarize, what this function is doing is that it calculates number of videos that a category has in the trending tab per month. And let's run it. So we can see that, for example, gaming in April had 17 videos and sports had 28 videos. We can also see the boundaries. Lower boundary is the first day of April, and upper boundary is the first date of March, actually. So in this case, we're actually making a mistake and we're calculating a month plus 1 day, which is fine for now because we don't use this analysis anywhere. But when you do your own, make sure that you specify this closed correctly. Let's actually change it to left. And now we're going to include only left and not the right. Perfect. So how do we visualize this? Let's make a line plot that is going to show number of unique videos per category per month, and that's where the top categories come in, because having too many categories can make the plot a bit cluttered. So here I'm just filtering for the categories that are in these top categories, and let's plot it like this. And this is what we can see. Music and entertainment are undisputed winners. Music takes a clear lead from 2018, which actually might signify some sort of a maybe change of strategic direction for YouTube, that they decided to push more music videos than entertainment videos. Or there was simply more music content than entertainment one. There is one disadvantage of the analysis we've made, that it's using this data frame, which had, as you remember, duplicated videos. So in theory, the counts here are inflated a bit. So it would be better to use the data frame that we came up with previously, right? When we did this aggregation. Let's scroll a bit up here, this one that contains only unique videos. And let's scroll down and do this analysis. We're going again to use the same group by dynamic. By now you understand what it does. It aggregates by time. And we're going also to do everything the same, just specify index column not as a trending date because this column is not available anymore, but it is called first day in trending. And what we also want to do here is to sort this data frame according to the date column that we are using as an index. And this is important for the aggregation to work properly. Everything else remains the same. We're still calculating number of unique videos and doing the same type of visualization. And as you can see, the total number of videos drops. And you can see that actually entertainment and music now don't have such a huge distinction. And this just tells us that music tends to stay in trending longer. So that's why we see this effect. And this also corresponds to the analysis we've made here and the discovery, right? That music is the longest type of videos in trending. And let's scroll back. Everything else stays the same. We still have these two undisputed leaders, entertainment and music, and everything else is below them. As the last step of this analysis, let's calculate running average views per category. More specifically for two categories that we saw were above everyone else, so the music and entertainment. And to do this, we're going to use group by rolling. As you could get from the name, it's used to calculate rolling features or running features, whatever you want to call them. But before doing this, we need to get the data into the right format, and this is what this cell is doing. As you can see, we're grouping by category ID and trending date, and then just summing up the total number of views for a category. And what we want to end up with is a data frame that tells us essentially how many views each category had per day of trending. In this case, we don't really care about uniqueness of the videos, so we can use the original data frame. And let's run this. You're already familiar with group by and aggregates. And we also need to make sure to sort by both of them, category ID and trending date. So this is a requirement for the group by rolling to work properly. Let's actually not sample, but let's head so that you can see lots of vehicles, and then it performs the sorting by date. Now that the data is ready, let's apply group by rolling. And all we need to specify here is a period over which we want to make an aggregate. In this case, it's 1 week, so it's going to be a 7-day running average of views. Then we need to specify by which column do we want to group by our data, and it's going to be category ID. And then we want to specify what is the date column, and this is trending date. And that's pretty much it. So we can do aggregation is done the same way. As you can see, API is very simple. It's one of my favorite parts about Polars, is that API is very thoroughly thought about. And we calculate the mean, number of views, and calling in rolling weekly average. Let's do it like this. And we can see that it outputs something. So how it looks like, well, let's see. And this is the data. You can see that number of views that music videos bring in is disproportionately large to the number of views that entertainment brings in. So this is another reason why probably music videos stay in the trending a bit longer. And there you have it. We've covered a lot of ground, so let's just summarize everything. In the beginning, we loaded in our data and pre-processed it, just like in the previous project. Then we did some basic feature engineering. And the first thing you saw here that was new is the operations with date and how nicely you can calculate the date differences. Then we saw operations on date, how to extract week date, month and year, and how to work with strings, for example, to split them according to a separator. Then we moved on to aggregates. The first aggregate that we've covered was the group by operation, and we used it to devise a lot of interesting features, such as time to trending, first day in trending, last day in trending, and the days in trending. And then we used these features throughout our project. Then we created a function that could be applied to many columns to create nice aggregates. And finally, we moved on to a group by dynamic, which is used to aggregate data according to some sort of a dynamic attribute. So in this case, it's a date, and we're specifying a period at which we want to aggregate. In this case, it was 1 month. So that's how it looks like. And then we finally moved on to group by rolling, which is used to calculate rolling or running averages. We calculated rolling weekly average of views that each category had, and we also visualized it using Seaborn. That's it for today. Thank you so much for watching. I hope you liked it. I hope it was clear. If you have any questions, leave them down below. I will make sure to answer them. New videos about Polars are going to come out soon, so make sure to subscribe to not miss them, and I will see you in the next one.